I'll be taking you through the introduction, and then Terry, who is our Chief Product Officer, will give you a demonstration of live troubleshooting of CASB performance in real-life scenarios. So I'll just take you through a little bit of the history of CASB. We see that the pandemic and work from home certainly had an impact on the security perimeter of different organizations who now have highly distributed workers. We're seeing in the latest results from surveys from McKinsey and Gartner that well over the majority of employees are now primarily working remotely, and this has a dramatic impact in terms of where the traffic routes through the network, how it gets to the cloud, and also in terms of security. So in response to that, and we'll see why in a few, 3/4 of enterprises will be using or planning to deploy CASB in their networks to secure them within the next 2 years. In addition to that, the CASB is part of the larger secure access service edge market, which is the fastest growing segment of security today. So it's an area definitely to pay attention to, and also that will have a lot of impact on enterprises in the next couple of years. Just to look at what CASB is, so that it is a cloud access security broker, and essentially it's normally provided as a cloud hosted service, although you could host it privately in your own premise as well. Essentially a distributed gateway that seeks to allow people to securely connect to cloud and SaaS applications. Make sure that you have the capability to enforce who's accessing them and what rights they have, and to make sure you don't have any data loss or security breaches. The way that users connect through a CASB is through a local proxy, the closest one normally that's available to them or on premise, and that CASB proxy will then determine the security parameters that they're entitled to have. And CASB is seen in the larger market as part of a full secure service edge strategy, and is often integrated into SD-WAN integrations with either the same vendor that's supplying the CASB or different vendors. So you'll see that this is more of a broad fabric that's starting to really replace the traditional connectivity that enterprises have been familiar with in the past. So we'll take a look here at some of the leading vendors in the CASB and secure service edge space. Many of you are probably familiar with Zscaler and Netskope, which are the more predominant players both in market share and also in terms of technology coverage. But from a Kadiska perspective, we also see quite a few other players that are extremely popular with our customers globally. So we do see Cisco, and Microsoft has a significant CASB offering, and ForcePoint is also quite popular in the network. So we see quite a few different CASBs being used across large enterprises today. And we'll take a look at how those ones are performing and compare them to each other later in this webinar. How did the CASB really become a necessary element? If you look at the security perimeter from the past in the legacy IT environments that are more traditional in terms of having private data centers or infrastructure as a service, branch offices would typically connect into headquarters or larger enterprise sites through private line, could be MPLS, could be a secure Ethernet or E1 type connection. Or if it's a smaller site or remote worker, a VPN would be used to access the headquarters, which would then firewall all the traffic going out to public locations or private data centers through secure links. And this was a very simple security perimeter to maintain because everything essentially went through the corporate LAN before it reached the application endpoints. When we look at the more modern cloud-centric and software as a service powered enterprise today, there's a lot more distributed users, a lot of people working from home in different locations, and they're more likely to directly access SaaS and public cloud applications and databases directly because of the performance benefits of that, and also because a lot of the devices that people are using working from home might not be the ones that are provided by the enterprise. So a very different landscape showing up. In terms of connectivity that used to be largely MPLS, we're seeing a transition globally. Right now, about 80% of enterprises are shifting to SD-WAN for branch to main site connectivity. The SD-WAN also allows connection to private data centers or infrastructure platform as a service, private cloud, and can also connect into SaaS applications through localized peering arrangements. But SD-WAN doesn't offer really any difference in terms of security, and that's where the CASB became a necessity in this kind of highly distributed traffic environment. So the CASB's role is to secure the entire distributed security perimeter. And you can see here how these icons here represent proxies that either the branch traffic, like a retail location or a manufacturing site, or a remote user working from home, or even the staff and employees at a main enterprise site would use to access the cloud and SaaS application. So the proxies here are then responsible to secure the connection, make sure that the users have the right to access the applications that they're attempting to access. Originally, CASB was designed to allow IT to capture traffic to SaaS applications that weren't authorized by IT. So essentially to keep an eye on what you would call shadow IT. And now, of course, expanded to a much larger role. The top 5 things that CASB is required to do in terms of their market definition: cloud application discovery, so understanding what's being accessed and also assigning a risk level rating to those to determine which ones may be potentially important for IT to be aware of. Access control in the sense of a zero trust network. Preventing data loss from the servers and clouds and applications that are connected to. And this means essentially keeping corporate data safe, making sure that the data is not leaving the security perimeter to another location. Then, of course, the concepts of threat protection and making sure you understand the behavior of individuals and what they're doing. So a lot of people ask us how exactly a CASB can impact the performance of the organizations that are using them. And this is quite an important topic because CASBs can have a significant degradation on performance for SaaS and cloud applications. Thierry will show you often introducing quite a bit of latency or errors in terms of transactions that are being processed by the different SaaS and cloud-based applications. So the way these CASBs are work in most applications is that different proxies that are cloud hosted are located in important regions around the world. And hopefully your CASB provider has proxies in locations that are very close to your corporate sites. And we'll show you how you can actually assess whether they are close enough to help users have a fast user experience. The first way that CASBs can impact performance is that the proxies themselves can be slow to respond. They can be slow to process the security requests with the different cloud applications and also the device that the user is connecting to those applications. So processing delays can be introduced simply because of the volume of traffic or if their cloud performance is not working at maximum quality on that day where you're accessing these resources. The second way that CASBs can impact performance is through the lack of a local proxy. So in this case, if you imagine that this proxy that the user is connecting to is pretty far away from them, maybe 30, 40 milliseconds away on the other side of the country, for example, they will introduce latency getting to the proxy. There will be time delays while they negotiate the security parameters between the device and the proxy. And then forwarding the traffic on to the applications the user wants can be significantly impacted by this kind of transit delay. The other one, which we see quite often, which is even more impactful, is if a user is trying to access a proxy, but for some reason the local internet provider's DNS resolution or the BGP routing sends the user to a different location by geolocation to a different proxy, not the one that's closest to them, but one that's quite far. This can impact the application performance because it will likely forward on the request to a SaaS host or a cloud host that's not actually within the same region as the user. So it's not uncommon at all to see someone in, let's say, Germany connecting to a CASB proxy in India, and then this one will actually forward them on to a SaaS host in the United States. And this is extremely long, difficult impact in terms of performance. So now Thierry will show you how you can actually monitor CASB performance. We'll do a quick overview here, and then he'll take you into the Kadiska application to show you how to troubleshoot and benchmark CASB performance live.
So basically, to monitor a CASB performance, we have two ways to do that. The first way is via what we call the stations. So a station is nothing else than a small Docker container you can deploy on any systems you like. And basically, this container, this station will perform active tests to SaaS applications or to CASB provider just to measure, first of all, the network connectivity performance going to these SaaS applications through CASBs, as well as the full network path, so that you can really understand from the station up to the destination all the routing path that is being taken and identify, for example, non-optimal redirections, like Scott mentioned, non-optimal redirections to faraway proxies instead of connecting directly to the closest proxy. All the collected data are sent to a platform, which is SaaS-based, the Kadiska platform, for storage, analysis, and troubleshooting. Then the second technology we use is what we call the watcher. So in a SaaS type of application, a watcher is a small browser extension you can easily deploy on all your employees' browsers. And the watcher will in fact collect performance metrics directly from the browsers of the users. So it will provide us with a lot of useful information, like the context of the users. How do users connect to the SaaS application? Do they connect through VPN concentrators? Do they connect directly from home to the SaaS without passing through a CASB? Do they connect through a CASB? And if they connect through a CASB, what's then the impact from a performance standpoint? Not only from a connectivity performance standpoint, but also from an application behavior performance standpoint. So here you see the Kadiska platform, and I will try in a few minutes, I will try to show you 4 different usage of the Kadiska platform when it comes to CASB performance monitoring, just to give you a sense of what we can do with Kadiska. In the first scenario I will show you, I'm interested in knowing which kind of CASB performs the best. So when users connect to a website, which CASB delivers the best performance connecting these users to the Kadiska website? Seeing that we are totally independent of any CASB provider, we are able automatically to detect how users connected to our website. Did they connect from home? To which local operators they were connected? Did they connect from a corporate site? And in this case, sometimes users were connected through Zscaler, Onescope, or Cisco, or other type of CASBs. So in this case, I would like to focus my attention on the CASBs themselves. So I will filter on the gateway, and I will here focus on Cisco, Forcepoint, Fortinet, McAfee, Microsoft, Netscope, Palo Alto, Proofpoint. All these CASBs are automatically identified by the Kadiska platform and Zscaler. I save it, I apply the filter, and now I see only the users that connected through the CASBs, and you see here really easily the impact of, so who was the best performer. So in my case, I can see that McAfee was the best performer because the users that connected to the Kadiska website through McAfee had an average connectivity of 12 milliseconds versus Forcepoint in this case, 143 milliseconds. Obviously, you could argue, because this is an overall performance independently of the user's location, so you can argue that potentially the performance will not be the same for European users. So yeah, and you would be right. So let's focus on these users. So here from this table, I can group by continent and focus, for example, on users located in Europe. Again, I can benchmark the different CASB providers for users connecting from Europe. And you see that, again, the best performance is still McAfee, and the worst performer in this case is Microsoft. Then in the next example, I'm a Zscaler customer. So let's assume that all the traffic passes through the Zscaler. And now the question is, what about Zscaler performance connecting my users spread over the world to my Kadiska website? So I will get rid of the continent here, and I will, for example, group by countries. And you see here the worst connectivity per country. so that I can see that, okay, I have potentially users located in Italy, and for these users, Zscaler is not performing so well compared to, for example, users that connect from Denmark or Brazil or Japan. Okay, so really easy if you are a CASB customer to assess your CASB provider performance according to your user's location. Then in the next example, I will focus my attention on one specific user. So I just go to the user ID and I focus my attention on myself. I basically connected through Proximus, which is my local provider here. And I also connected to Proximus being on site, Proximus being remote, meaning this is when I use my 4G connection of my GSM to connect to the website. And then I enable this morning my Netscope client so that I can really measure from an end user experience point of view what the impact was using Netscope instead of reaching my application directly without going through a CASB provider. A network latency of 58 milliseconds connecting to the website. Without passing through the CASB, I had a 12 milliseconds network latency. I can immediately see what the impact was using my Netscope Cloud Access Security Broker solution. Now the question would be, did it affect my overall application performance? This is what you can see here. So processing has to do with all API calls and all transactions you made to the application, and you can here assess that in fact going through Netscope had a network latency impact and have had a small impact on the application transaction. Then the last thing I would like to show you is, now let's assume that I see a big increase to connect to my local proxy, and I would like to understand why. The watcher provides me with this information about the performance impact going through a CASB will have, but where the degradations come from. Does it come from an abnormal redirection to a far away CASB proxy? Or does it come from the CASB provider service itself? Or does it come from the network between the user and the local CASB proxy? I'm connecting from Belgium. So let's focus on Belgium and target, which is my CASB provider, Netscope. And let's take the 3 last days, okay? And then in this case, what I can see is the past performance. So you see remember the 29 milliseconds? Now I have this information over time, and I can see if I have some degradations connecting to the SaaS application through a CASB provider. And now I'm able to identify the full network path that has been taken by the traffic. So I'm connected, as I told you, I'm connected on Proximus, my local operator here. And Proximus, I can tell you that Proximus, in fact, peers to the Belgacom International backbone. And then before reaching EX public network, before finally reaching my Netscope local proxy, which is not located in Belgium, by the way, it is located in the Netherlands. And that I do not have any big issue here from a network connectivity point of view. I was not redirected, but this is the last part I would like to show you is how quickly I can troubleshoot problems if they occur. So for that, I will go back the overall network connectivity performance connecting to my CASB from all my different locations all over the world. So you see that we are actively testing the network performance connecting to my CASB from Japan, Russia, United States, China, and so on and so forth. And I can tell you that, for example, from China, connecting through Netscope CASB to 246 milliseconds, which is quite high, but this is stable. What I'm trying to look for is abnormal behavior, like this one. You see here from India, Nashik, I have a lot of network latency variations connecting to the Netscope proxy. So now my question is why? What does this come from? To answer this question, I simply click on the India Nashik location. I go to the past performance to understand what happened. And you see here that basically I had an average connectivity here, network connectivity of about 30 milliseconds, and it fell back to 2 milliseconds. I can see is that my local operator here from a BGP point of view peers with two different operators. One is Tata Communications and the second one is WebWorks, which corresponds to the best performance and the worst performance. I simply take a time frame corresponding to a high latency and immediately you see what happens. Here, I have a bad performance connecting to my local CASB when the traffic was routed to Tata Communications. And when I select a good performance from a network connectivity point of view, that it corresponds to the traffic being routed to WebWorks. The extra latency I see here does not come from a redirection here. It should come from a network itself. And you see indeed that 27 milliseconds delays was generated within the Tata communication network backbone. And this is how I can quickly troubleshoot a connectivity issues by understanding, does it come from a routing problem, a node degradation, or a local CASB proxy redirection problem?